Hi, my name is Sarah and this video will be about solving a problem from Unit F, Concept 10. So here we have our polynomial to the fourth degree. F of x equals 4x to the fourth power minus 26x cubed minus 22x squared plus 11x plus 3. Our first step is to find the factors of the p's and q's of this polynomial. The p would be the constant, which is 3, and while the q would be the leading coefficient of the polynomial, which would be 4. And the factors are q equals plus or minus 1, plus or minus 2, and plus or minus 4, while p would be plus or minus 1 and plus or minus 3. Now, to find all the possible real and irrational zeros of this polynomial, we will divide all the possible factors of p by all the possible factors of q. And we get p divided by q equals plus or minus 1, plus or minus 1/2, plus or minus 1/4, plus or minus 3, plus or minus 3/2, plus or minus 3/4. The next thing we need to do is determine the number of possible positive and negative zeros there are in this polynomial. To do this, we will use Descartes' rule of signs. We take the signs of each term in the polynomial and write them out. Then we notice how many times we get a sign change, such as in f of x, we have 2 sign changes, which means that there are 2 or 0 possible positive solutions. Let's try that with f of negative x. Remember, the sign changes for the terms with the odd exponents, but not with the even. As a result, we get plus, plus, minus, minus, plus. That's 2 sign changes, which means that there are 2 or 0 possible negative solutions. Now we can finally start on the synthetic division. I think I'm going to try -1 first. And hooray, we have a 0 here after synthetically dividing -1. And so now we know that -1 is one of our zeros and x plus 1 is one of our factors. Let's try another number using our new synthetic bar. I think I'll go with 1/2. And we get another 0 here. Now we know that 1/2 is one of our zeros and x minus 1/2 is one of our factors. Now every time we divide synthetically, we can reduce the greatest exponent by 1. Therefore, since we have divided the polynomial twice already, we now have a quadratic that we can solve. As you can see here, I've already added in the variables. We factor out the GCF from this polynomial, and we get 2 times the quantity of 2x squared minus 14x minus 3. Using the quadratic formula, we can solve this polynomial. Remember, it's -b plus or minus the square root of b squared minus 4ac over 2a. Once we plug in the correct numbers, we are good to go to solve. We find that our 2 remaining zeros would be 7 plus the square root of 55 over 2 and 7 minus the square root of 55 over 2. So in total, our 4 zeros would be -1, 1/2, 7 plus the square root of 55 over 2, and 7 minus the square root of 55 over 2. And we can for the factorization of the polynomial, we have 2 times x plus 1 times x minus 1/2 times 2x squared minus 14x minus 3. We can simplify this even further. If we distribute the 2 to x minus 1/2 only, we get x plus 1 times 2x minus 1 times 2x squared minus 14x minus 3. Okay, that was my video on Unit F, Concept 10. Hope you enjoyed it and thanks for watching.